So what we're going to look at now is factoring trinomials predominantly. And there's a few cases that we have to look at. But basic factoring, for all intensive purposes, is reverse distribution. So case in point, if I look at 5 times 2 plus x, and we do the distribution, we all know that that's going to be 10 plus 5x. Now, if this is the distribution, then if we go backwards, we're just doing the factoring. And what you can notice about this expression is that both terms have a factor of 5 in it. So we can rewrite this as the 5 times 2 plus the 5 times x. And now it's very easy to see that both of these factors have, well, each of these terms have a factor of 5. So what we're effectively doing is pulling out a 5 from each one of these terms. So what we have here, is 5 times the quantity 2 plus x back. So this is just a way of going backwards and forwards. So if we look at a specific easy example, and let's just say that we have 3x minus 15x cubed, and we wanted to completely factor this. Well, that's easy, this nice polynomial expression, because both of these terms have a factor of x and a factor of 3. So we can rewrite this as 3 times the x, maybe, and then minus 3 times 5, maybe, times x squared. So what did we do here was just break these apart so we can easily see what's common between them. So in this case, we can clearly see that in both cases, a 3 and an x are common. So what we'll do is we will factor those out. So we'll have the 3x outside the parenthesis now, and then what's ever left over. So from here, if we're factoring out a 3x from 3x, we have a 1. And over here, if we factor out a 3x, we have just the 5x squared. So if you actually do the distribution, do you come back and end up here? So that would be 3x times 1 minus 5x squared. So this would be 3x, and this would be minus 15x cubed. So it does look like we come back to the same thing. Okay, now there are a few special cases, but one of the things that I am going to show you right now is factoring any type. But we'll do it with a nice example to start. So what we want to do is we want to factor the following. Let's say that we want to factor x squared minus 10x plus 25. So this is a special case, but we'll come back to that. Just to remind yourselves what the standard form for a polynomial expression is ax squared plus bx plus c. So in this case, we can identify what a is, what b is, and what c is. So a in this case is 1, because we have 1x squared. B is the negative 10, and C is the positive 25. So what we need to do is, they're mowing the lawn. That's great. So what we need to do to factor this completely is to find the factors of C that combine to B. So in this case, we're looking for all of the factors of 25. So if we just do this and we say C is equal to 25, and we need, it's actually AC, so I should fix this. Find the factors of AC that combine to B. Let's just do it this way and kill two birds with one stone. Okay, so we're looking for this product. So all the factors of that product, okay, that we can think of, right? So there's 1 and 25. Well, 2 doesn't go into it, 3 doesn't go into it, 4, 5 and 5 do, right? So we don't have to check anymore because we're back at those factors, and these are all the factors that line up. So now, what do we have to do? We have to figure out a way that A and C have to equal B. And in this case, what number are we looking for? Negative 10. Now you'll say to yourself, well, some of these numbers don't have negatives in it. But there is one set of factors that we sort of neglected by habit. Oh, wait a second. Doesn't also negative 5 and negative 5 work? Doesn't that also give you a product of 25? So what we're saying here is that we're looking for any of the factors that can somehow combine to negative 10. So it looks like the only one here would be this, the last one here. And that would give us our negative 10. So at this stage, we know both of our factors. Why is that doing that? We know both of our factors for this binomial. So what we have to do is write down our binomials. And then let's just write down what it equals. It's going to have to equal this beastie. So that means that we have 1a. Well, that just means that all we have to do is place both x's, because we're going to have to end up with x squared at some point. And then what are we going to notice? Well, we notice that both of these factors were negative 5. So all we have to do is bring down each one of these, and we have factored this out. Now we can rewrite this, and I told you that this is one of those special cases because we have the same base twice. So this is x minus 5 all squared. And this highlighted here is the factored form. So what happens if a isn't 1? So if that's the case, let's try another special type of example here. And I'm hoping you start to see a pattern between these special ones that we're building. But if we do another simple example here, and what we want to do here is factor the following. So we want to factor 16x squared plus 24x plus 9. All right, So we want to find the factored form of this. Well, first of all, we're looking for any common factors. There's really no great common factors here that we can really look at. So let's just go right for the meat and potatoes here. And here we go. So what we need to do is find the product AC, and then we are going to have to find all the factors of it. So what do we know? Well, we know that A is equal to 16, we know B is equal to 24, and we know C is equal to 9. So this one might take a little bit more work, but we can list them all out. And we're going to save a little bit of time to do this, but so what is the product AC? Well, it's just going to be 16 times 9. So we have to find all the factors that would break up nicely. So if we look at this, well, clearly we have the factors 16 and 9. That would give us that product. And is there any way to get 24 from that? Well, what if one's plus, what if one's minus? Well, let's see, because remember, we're trying to get A plus C to equal B. In this case is 24. So let's try thinking smart about this and write down all of the factors at this point, because let's take a little note out here and actually say what this is. Well, this is 16 times 9, and if we just do like a basic factor tree, we might be able to play rearrangement of all of these. So this is really just 4 times 4, and this is really 3 times 3. Well, whoa, there's a pattern, looks like. Whoa, that's kind of neat. Okay, so we can actually put all of these factors together, right, and multiply them. What I'm getting at here is if we multiply 16 and 9, we're going to end up with 90 and 54, or 144. So what we need to do is find all the factors of this that can combine in some way to 24. So we're breaking them down into a factor tree in order just to show you that there might be a special pattern developing. So all of these beasties we can now look at. So what we always have to do is come up with something that's this value, right? Well, wait a second. This is 12 times 12. So I wonder if we try 12 and 12, is there some way to combine those numbers? So in this case, we could add these, and that's not going to give you the number. You could take this, and that's not going to give you the number. You could take this, and that's not going to give you the number. So any way that you're really looking at this, you're not going to get back to 24, which is what you want. So there's no way to get those here, but it looks like if we add those two together, we do have a possibility of getting 24. So now what do we have to do? Well, we have to look at what this actually signifies to. And what we gotta try to look at here is, I just messed up. The mess up wasn't actually in the problem, it was me hitting the button. So we're good at what we have, so let's rewrite the problem now. So I can't, sometimes I have trouble. So let's rewrite the problem, just so we have it nice and clean. So we have 16x squared plus 24x plus 9. And what we're saying is that we can now break this 24 up into two values. So we can have 16x squared plus 12x plus another 12x plus 9. So notice that all we did was we broke up this 24x into the two components of 12 and 12. And the reason being is now we're going to look for common factors between this grouping and this grouping of items. So let's put this together, and I'll do this in pink. So what does this look like, the first one? Well, that's 4 times 4x squared, and that's really plus 4 times 3x. So it looks like right here we have a commonality. Why does it do that? Okay, so we have a commonality of 4x. So let's pull out the 4x, and that means that we're going to have, well, what left over? Well, that means we're going to have 4x squared, and then plus what? Well, what are we going to have left over in the secondary one? Just plus 3, right? So you can double check and see, do you get the 16x squared plus 12x? And if you go back and mentally do that, you'll be able to see that it is in fact true. So let's do this other one in blue here. So are there any commonalities between the 12x and the 9? Well, 12 again is just 4 times 3x, and then 9 is just 3 times 3, so both of those have a factor of 3. So what we can do is we can factor out the 3, and now what's left over from this beastie? Well, if we factor out a 3, it's just 4x. Now I made the mistake. Did you catch it? Okay, you'll see that I saw it right this minute because I was trying to rush. But then what's left over is plus 3. Now, there's a special note here. Mistake was made. That's okay. What did I not get the check, which was right here? If I go back to pink, then this should be that. And I did it a little too quickly, and I'm sorry about that, but let's show you what I mean. So because each one of these factors has a 4 and an x, there's one x being removed from here, and I just rewrote it because I was doing it too quickly. But what sign then goes in between all of these? That's a good question. Well, notice that the number that you're getting is positive in either case. So this would be a positive and a positive. So now what we can see is that both of these factors here have a commonality of 4x plus 3. And that means we can pull that out. So that would be 4x plus 3 times something that's left over. And now we just have to see what's left over. It's the 4x and the positive 3. So it looks like this is 4x plus 3 squared. So sorry about that little mistake there that we had, which was right here. So I'll make note so I don't make that again. But I'm hoping that you see that pattern that we've been building. Do you see in the original problem here, if I rewrite the original problem, so let's just do that. If I rewrite the original problem, 16x squared plus 24x plus 9, and if you notice this, that this is really 4x all what? Squared. And if you saw this, which is just 3 squared, and you notice that what is the 3? Well, it's positive. So if we look at this, at this point, do you see the pattern? We can build it right away and see that, well, we do have that nice square. So you really need to check it very quick, but if you see it, then that's just great. And if you want to definitely prove it, you need to know that the internal product, this 24, is 2 times the first times the second, and we should have 24x, which is the same darn thing. So a lot of ways to look at it and a lot of ways to do the factoring. Just keep in mind that there are special ones, and this is a special. And the idea here is for this special kind is to look, is the first term, if it's in standard form, if the first term is a square, and the last term is a square, then you might have this nice perfect square to work with.